In this section, I will compare R tool with Excel, and I will also show some of the working examples in R. For example, how you can represent data in R and what are some of the data types supported by R. And in the end, I will talk about some of the best practices you can use to write R code. There are many reasons why R is simple and better than Excel. For example, R is free and well documented, and you will find a large online community where people are supporting R tool. Also, R can be run on many platforms. Whether it is Windows, Mac or Linux, you can easily install R on any platform. Also, R has more advanced statistical packages for data analysis, and R provides you more powerful data processing capabilities. So you can read any type of data in R. For example, R can read raw data, R can read unstructured data, and R can also read structured data. R also supports large and big data files. Whether the file is in kilobyte or megabyte or gigabytes, R has the power to read the data and have the ability to process big amount of data. And finally, the graphics and the plots in R are much better than Excel. You will find many state-of-the-art graphics in R which are especially designed for data analysis. Let's take an example of some of the operations which can be performed both in Excel and R. Let's suppose you want to add two columns in Excel. So what you do is like you first add two numbers and then fill the addition column with the formula, and then you get the output. In the R, you actually create variables. So for example, in that case, you are creating a variable A, and this is the assignment operator. It means like you are assigning these values to variable A. Similarly, you created variable B, and to add these two variables you just say A plus B and you will get the output. So you can see that like it is very simple in R to add two numbers or two columns or two rows. Similarly, if we want to multiply a column with some constant, as in the example of the Excel, you wanted to multiply a number 33 with the column C. So what you do is like you say C1 into D1 and then copy the formula down the column. In R, you can simply say C star 33. It means you are multiplying the constant 33 with all the values in C and you get the output. Similarly, you can use the exponential function in Excel by using exp, and in R you just call exp 0:5. 0:5 means you want to calculate the exponential function of value 0, 1, 2, 3, 4 and 5. Now there are some of the operations which cannot be performed in Excel. For example, R can read any type of data. It could be a text file, it could be a CSV file, or it could be a DAT file. For example, to read a CSV file in R, you can actually call a function called read.csv and the file name. Some of the packages, R packages, can also read JSON file. JSON file is a very well formatted web server data file. So you can install a package called rjson and you can actually read the data using from JSON function. R can also read website data in the XML or HTML format. For example, if you want to read and analyze the content of CNN.com, you can actually call a library called XML and you can call a function called read HTML table and give your URL. And in that way, you can actually read the actual content of the website and analyze it. And at this point, you already know about the structured query language, so you can connect R directly to the database and you can use SQL language inside R. For example, you can create a connection to the database using ODBC connect, and then you can write your SQL query and execute it directly from the R. As I said earlier, R can read big data files. So in this example, I am trying to read a data file which is about 8.1 gigabyte of size. So you can see that R can easily read such a big file which has about 89 million rows and 20,000 columns. So if you compare this number with R, you can see that the Excel cannot read more than 1 million rows and about 16,000 columns. So this is the limitation of Excel, and you can easily overcome that limitation by using R tool. R also supports variety of graphs and plots, and R is extremely flexible when it comes to making meaningful graphs. For example, in that graph, you are actually comparing 4 different characteristics with 3 different categories, and you can easily generate this graph by using a very few lines of code in R. This is an example of the scatter plot generated in R. So you can think of a scatter plot is if we wanted to compare two attributes or two features in the data set. For example, in that case, I am comparing 4 different attributes with each other. So you can think of generating this plot in Excel, that you have to put a lot of effort in generating this graph in Excel. In R, you can easily generate this plot by using just few lines of codes, and since now we have only 4 attributes, think of if we have like tens of thousands of columns or attributes, and if we wanted to compare with each other. So it would be very inconvenient in Excel to analyze such kind of data. But it is very simple and flexible doing it in R. Let's talk about some of the data types we used in R. Vector is a collection of similar elements. So in the first example, you can see that I am creating a vector called X, and the X contains similar kind of elements which are all numeric. You can also create vectors in the form of colon. So if you want to have the values from one range to the another, you can easily use colon sign, and if I say 2004 colon 2010, then it will generate all the values starting from 2004 till 2010. And you can see that I am saving all the values in a vector called year. And after you created vectors, you can easily perform a large number of calculations using a single command. For example, I wanted to multiply a constant 3 with the whole vector x. So I can just say x star 3, and it will multiply 3 with all the elements in x. So as you can see that in the x I had 1, 2, 3 and 4, and when I multiply with 3, I get 3, 6, 9 and 12. You can also perform operation between two vectors given that they are of the same length. So I created another vector called y, which contains values 1, 2 to 1, and you can see the length of y is 4 and the length of x is also 4, and I can perform the arithmetic operation called addition between these two vectors. And when I say x plus y, then it will add all the values of x to all the values of y. So if you are familiar with the Excel, you can think of vectors as one column or one row in the Excel. Another data type is called matrix, and matrix is a vector with 2 dimensions. So in that case, we have both rows and columns in the matrix. So in this example, I am creating a matrix of 6 elements which has 3 rows and 2 columns. So if you look at the left side, it shows the number of rows, and on the top it shows the number of columns. So matrices are used in mathematical calculations, and when we develop some algorithms, we definitely use matrix in it. And if you wanted to find out some of the properties related to matrix, you can use different kinds of functions. For example, I created a matrix which is, I call it mat. Then when I call a function called class mat, it gives me the class of that matrix, and in that case I have a class called matrix. If I say is.vector mat, then it gives me false, because mat is not a vector. Mat is a matrix which has both columns and rows in it. If I say is.matrix mat, then it returns me true, which means yes, mat is a matrix. And if I wanted to find out the length or the number of elements in that matrix, I can just say length mat, and it gives me 6, which means I have 6 elements in that matrix. And if I wanted to find out the number of rows and columns in that matrix, I can just type dim, which is dimension, mat, and it gives me 3 2. The first value represents the number of rows and the second value represents the number of columns. So far we talked about vectors, which is one dimension. We also talked about matrix, which is two dimension. And if you wanted to go beyond two dimensions, you can actually use arrays in R. So arrays are the matrix which supports more than two dimensions. So in that example, in the first example, you can see that I am creating a two-dimension array which looks exactly the same as matrix. And if I wanted to create three-dimension array, I can use this command. And you can actually see that I am storing two different matrices in one array. You can also use some of the functions to get the information about your array. You can use length of your array, which gives you 12 because I have 12 elements in that array. You can use dimension b, and you can use is matrix function, and you can also use is array function to get the information of your array. Another data type in R is called list, and list can store different elements in it. For example, the elements of list can be numeric vectors, can be character vectors, it can be matrix, and it could be arrays. So for example, in this case, I am creating a list called L, and it contains a vector, it also contains a string, and it also contains some boolean values like true and false. So you can see that a list can store different kinds of elements in it. So you can also use some of the functions called length, L, class, and names, and it will give you the information regarding your list. So if you have the R Studio installed in your computer, you can actually try these commands. So if I say L and two brackets and 1, then it returns the first item in the list. So you can actually check the length of that item, and if I say L3 and 1, then it will return the first element of the third item in the list. So you can also check these commands in RStudio. One of the very important data type in R is called data frames, and data frames contain the structured data with a specific number of rows and columns. So as you can see in that example, I have a data frame called painters, and it has certain number of rows and 5 columns in it. So the elements of the data frame could be numeric, it could be characters, or it could be logical. But the most important thing related to data frame is that all the elements must be of the same length. So in this example, you can see that each record has 5 elements in it. So all the elements must be of the same length in data frames. And the data frames are extensively used in creating algorithms, data mining algorithms. So for creating data mining algorithms, we will be using data frames to create models. This is the small exercise for you on data frames, and you can use the same painters data frame which we have discussed earlier, and by doing this exercise you will be able to understand how to access different elements in the data frame and how you can perform several operations on the data frame. For example, you can perform the class function on the subset of data frame. You can also use the length function, and you can also use the dimension function in your data frames. So in the end of this session, I will show you how you can access this painters data frame in R. When you write a code in any programming language, there are some best practices which you can follow. And by using these practices, you can actually write a very clean and easy to understand codes. For example, you can use underscore while saving your R files. For example, if you are calculating a sum of some of the vectors or matrices, you can call this file calculate underscore sum.r, so that when you look at the file, you can easily understand what's inside this file. And you can also use dots or caps while creating a variable name. For example, if you wanted to store some test data in a variable, you can say test.data, or you can use caps like capital T and capital D to create your variable. So the basic idea is to use such file names or variable names which are meaningful, and by just looking at the name of the variable, you can easily understand what's inside this variable or what's inside this file. For the assignment, you can use two different types of assignments in R. You can use the arrowhead for assigning values to a variable, and you can also use equal sign inside a function to assign some parameters. And the third one is like you should always use hash function or hash icon to write the comments about your code. So when you are doing some complex calculation, you can actually write one line above your code describing what you are doing in your code. And this way it gives other user a better understanding of your code. And you should always use some spacing between your variables and operations. For example, if you look at that thing, I am assigning a value of 5 to a, and I am using some space between a, an operator, and a number. And it is always better than to have spacing between numbers. And if you have a very large code, you can actually divide your code into some functions so that it will be easy to understand and it will be easy to use in the future. You can avoid some of the common mistakes in writing R code. For example, brackets. You are going to use a lot of brackets in R code. So always remember to close brackets in R, because if you don't close the brackets properly, you will get some error. And there is a difference between using a single bracket and a double bracket in R. So make sure you understand the difference between these two. And since R can be run in several platforms, whether it is Windows, Mac, or Linux, so while creating a path to a file, you can use double slash in Windows, and you can use a single slash while you are working in Linux or Mac. And you can also look at the mistyping of the assignments, because this less than and hyphen is the assignment operator in R. So when I use this command, it means I am assigning a value of 5 to a variable a. But if you insert a spacing between less than sign and hyphen, then it means you are comparing a with -5. So make sure that you understand the difference between the spacing in the assignment. Regarding the operations, it's good to know the difference between single operation and double operation. So if I use a single ampersand sign, it means I am doing some logical operations or expressions, true or false, and while I am using a double ampersand sign, I am trying to check the condition in a statement or in a loop. The fifth one is very important. You should always remember to load a package after installing it. For example, if I wanted to install a package called mass, then I should follow the library mass after installing package. So whenever I am using install.packages mass, I have to install that library as well. So the install.packages mass should be followed by another command called library mass.